Okay, so now I'm going to do problem 6. Okay, problem 6, right over here, problem 6. And problem 6 is a doozy. Okay, so let's read the problem. So what does the problem say? It's a graph theory question. How many paths of length 3 are there in the directed graph at the right or on the right? Okay, so that means, so you have to first draw the adjacency matrix, and again the adjacency matrix would have a length of 1. Okay, so that would have a length of 1. So if you were looking for a length of 2, so you would have to cube the adjacency matrix. I'm sorry, you would have to square the adjacency matrix. Now this is asking for lengths of path 3, paths of length 3. So then what you have to do is you have to cube the adjacency matrix. Okay. So if you want to be able to do that in a reasonable amount of time, given the amount of time you have on the contest, you need to practice doing you have to practice it. So you have to practice doing the square and the cube. Hopefully you don't have to do the power of 4. So hopefully you won't have to do that. Okay, so what is the adjacency matrix? So the adjacency matrix has 3 vertices. So we have can't draw. So we have A, C, and D, A, B, C. Okay, so we have A, B, C. Okay, so we need to draw the adjacency matrix. So again, so it would be A. Now you should be able to do this. You should be able to draw the adjacency matrix without having to write out the letters, but you need to do that in practice. But just to show you, because it takes time to write out the letters. Okay, so can A from from A to A? So can I go from A to A? Yes. Can I go from A to B? Can I go to A to B? Yes. Can I go from A to C? Yes. Okay. Can I go from okay, now row B. Can I go from row B to A? Yes. Can I go from B to B? No. Can I go from B to C? No. Can I go? There's no arrow going from B to C. Okay, now on row C, can I go from C to A? Yes. There's an arrow from C to A. Can I go from C to B? Yes. There's an arrow from C to B. Can I go from C to C? Is there an arrow going back to C? Yes. Okay, so that's what the adjacency matrix looks like. Okay. But you need to be able to, write out the adjacency matrix without having to do that, because that just takes up a lot of time. Okay. So I've already done this problem ahead of time, and I've double checked it, and I've checked it against the answer in the PDF. So honestly, I did get it wrong the first time. So be aware that this takes up a lot of time to do correctly. It's very easy to make mistakes and get the wrong answer. Okay, so the adjacency matrix should be able to do it without having to. Okay, and then just the dot here. You can see kind of the dot. Okay, so then what is that? So this is the cube. Okay, so that's the cube. So then it would be, again, so it'd be, so you would be multiplying. Oops, sorry, that was wrong. I was doing it. I'm sorry. You're multiplying the rows against the columns. Okay. So what is so it'd be row A times column A. Okay, so what would that be? What matches up? They all match up, so that would be a 3. Okay, then it would be row B times column A. And what matches up? Only one matches up, so that'd just be 1. Then it would be row C times column A. They all match up, so that would be a 3. Okay. And then we go to the next column. Okay, column B. Okay, row A times column B. we have 2 matches, so that would be a 2. Then we go to row B times column B, and there's only 1 match, so that's a 1. Then we go to row C times column B, and there are 2 matches, so that would be 2. Okay, so now when we go to column C, and then column B and C, they're the same. The rows are the same, so just writing the same thing, so it's the same thing. Okay, so then we get this, and then we need to multiply by again by the same original adjacency matrix. Okay, so then we have to do that, and then that would give us the cube. Okay, I'm going to write out the cube here. So the cube would be, okay, again, it would be, right? So we have the rows and we have the columns. Okay, so again, it would be row A times column A. And then it would be row B times column A, and then row C times column A. And then once you're done with column A, then you would move to the next column. Okay, so what is row A? Row A times column A. So that would be 3 plus 2 plus 2. So that would be 7. Okay, then now we have column B times, row B times column A. Row B times column A, and so that would be a 3. So now we have row C times column A, and then that would be 7 also, 7 there. Okay, then we would go to the column B. So then it would be row A times column B, and so that would be a 5. Then we have row B times column B, and that would be a 2. Okay, and then we have row C times column B, and so row A and C are the same, so we would get the same thing. Okay. Okay, then we move on to column C. Okay, so then would be row A times column C, and that would be a 5. Okay, and then we have row B times column C, and so that would be a 2. And then we have row C times column C, and that would be a 5. Okay, and then what you do is just add up all the digits here, and then that would get us 17. And then we add up all the digits here, and that would get us a 7. We add all the digits, and 17. So what is the total? So the total is 17 plus 17 plus 7. And what does that get us? That gets us to 34 plus 7, and that would equal 41. So the answer for 6 is 41. Okay, how many paths of length 3 are there in the directed graph on the right, or at the right? 41. There are a total of 41 paths of length 3. 41 paths of length 3 in this direct graph, the directed graph of problem 6.